Okay, this is then the Year 8 energy tests, right, the knowledge test. Now, there's lots and lots and lots of kind of keywords and sort of understanding that needs to go in this, right, okay, so we really need to focus on this one, right, because a lot of this also comes up in Year 10 and 11. So what I'm going to do here now is I'm going to list the 8 stores of energy first and then give an example of each one. So we've got, oh my god, magnetic, don't miss out the A, thermal, we've got chemical, and we've got kinetic. I'll just write down 4 on that side, and then we've got gravitational, we've got nuclear, we've got vibrational, and we've got elastic. Okay, so examples. Magnetic, best example of that is a magnet. So what these stores of energy are is where energy is stored and then it can be converted into something else. Thermal could be hot water. Chemical could be a burger, it could be any type of food, it could be a battery. Kinetic is anything moving, I'll call it a bird. Kinetic, it could be a bird that's moving. Gravitational, we could have an arrow, right? So an arrow is above the ground and it's also got kinetic energy. Nuclear could be a bomb. Vibrational could be anything that is then kind of vibrating, so even like the particles in a solid. And an elastic could be a spring. Now, what we've got then is we've got those kind of stores of energy, and what they can then do is they can then be transferred into something else. And there's 4 ways of transferring energy, like 4 main groups. And what you've got to do is you've got to remember them as Herm, right? So we've got heating. So one energy can be transferred by heating something else up. Another one can be by transferring electrical energy. Another one could be like radiation. So you've got a hot object giving out different types of radiation. And the other one is mechanical, right? Mechanical is like a physical process of moving between one and another. Question number 3, what is the principle of conservation energy? It is where the amount of energy stays the same in a system. Okay, so conservation of energy, energy stays the same. What does dissipate mean? It means scatter in all directions, or to use wastefully, right? So dissipate, right, is literally, if I was going to dissipate a class, whether that's the right thing to do, they would scatter in all directions. Or to use something wastefully is to then dissipate something. Describe how the stores of energy are transferred as the pendulum swings, right? Now what you've got to do is you've got to then turn this into your own wording. This here has got a lot of gravitational potential energy because it is a way. When it moves, right, what it does, the gravitational potential energy turns into kinetic energy, where it's mostly moving. Then what happens, as it gets past the lowest point, where it's got its most kinetic energy, it then starts to slow down as it then becomes gravitational potential energy again. What is temperature? Okay, so temperature is a measure of the average energy of particles in an object. Question 7. How is energy transferred by conduction, convection and radiation? Conduction, convection and radiation. Okay, so conduction is direct contact. So if you've got a hot saucepan and you touch it, heat is conducted into you because it's direct contact. Convection is the mass movement of particles. Okay, often it says heat rises, right? So for convection, heat rises. So if you've got hot water, right, then you can feel the heat above it, right? That is then the convection that then comes off. But it's the mass movement of particles, and often, and kind of like in a simplistic way, it is heat rises. Radiation is anything from the electromagnetic spectrum, right? A good example of that is if you're sat in front of a fire, right, you can feel it. It's not by conduction because you're not touching it. It's not by convection because convection tends to be above. It's the infrared that is then coming out of it, which is your radiation. Explain how a cup of tea cools, right? So if I draw a cup of tea, right, this is then when you can see that I am amazing at art, right? What you've got at the top, you've got convection. Okay, that is then the heat coming out of the top. Out of the sides, you've got radiation, right? Because it's actually radiating out infrared energy. So if you put one of those infrared cameras on it, you would see that it's glowing. And out of the bottom, you've got conduction, because then there's the physical process between the cup and the desk, right? And if you then think about it, if you move a cup, the desk feels hot, and that's because it has then conducted out. Question number 9. What makes up the national grid? The national grid is made up by a power station. It is then made up by, I'm just going to write it down as SU transformer. Now that's being lazy, that is a step-up transformer. It then goes to pylons. I'm going to go backwards here. It then goes to a step-down, I won't be lazy, I'll just put P there, that's better, isn't it? Step-down transformer. And then it goes to the house or factory. So completing the table, advantage of fossil fuels is there are large reserves and it's also cheap. Disadvantages is the pollution and damage to the environment. Okay, so that's your coal, oil, gas. Nuclear advantage is no pollution, no greenhouse gases, and it's also pretty quick to actually make the electricity. Disadvantages is it's very expensive to set up, and it also has the potential for a disaster. Biofuel, this is then when you grow a crop and then what you do is then you burn it. Advantage is it is renewable, and it is also carbon neutral. Okay, so whatever you grow, you burn, right, it's the same amount of carbon going in either direction. Disadvantages is you need a lot of land. I don't know why I write toll, lot. Okay, and it also habitats destroyed, right? Because if you think about it, if you've got to do a lot of land to grow a lot of crops, then you've got to then take over habitats to do that. Tides, renewable, and there is also no greenhouse gases. Okay, so that's then taking the energy of the tide coming in and the tide going out. It is expensive to make, and it can also ruin habitats. All right, because you've got to build some sort of barrage across a river, then what happens, it affects upstream and it affects downstream. Waves, renewable, no greenhouse gases produced. Disadvantages, expensive, and it is also unreliable, right? You might get big waves, you might get small waves. Hydroelectric, right? What I'll normally do is I'll just normally call that HEP, which is hydroelectric power. Okay, I'm then just going to write down here renewable and no pollution. Okay, disadvantages with hydroelectric is it's expensive to set up. If you think it's going to be a dam, and because you're building a dam, you also ruin habitats. Wind, renewable, no pollution. Solar, renewable, no pollution. Geothermal, renewable, no pollution. Bit of a cheat, okay, you can't do that, all right, but I can. Wind is again expensive to set up in the first place, and it is also not reliable. You know, it's either windy or it's not windy. Solar is expensive, and it's also not reliable. You know, if it goes cloudy, you're not going to make as much. Nighttime, you're not going to make as much. And then geothermal is expensive, and it is only in certain places. So places like New Zealand, Iceland are good places, but very, very few other places in the world can use it. What is work? Work is the transfer of energy. If you think about it, that's what I'm doing now. I'm doing work and I'm transferring of energy from me to whatever work I'm doing. And the formula is work done equals force times the distance moved. So work done is measured in joules, force in newtons, distance moved measured in meters. What is power? Power is the rate of transfer of energy. So if you've got two bulbs, a 10 watt bulb and a 100 watt bulb, a 100 watt bulb can transfer energy quicker. And the equation for that is power equals work done divided by time. Power is measured in watts, work done, we just did it, is measured in joules, time in seconds. Final bit then is on the key words. A material that conducts charge or energy well is a conductor. Metals are good at it. The movement of heated liquids or gases, convection. Objects are at thermal equilibrium when they are at the same temperature, equilibrium. A material does not conduct electricity or transfer energy well, insulators like plastics. The unit energy symbol J, joules. Energy resources that have a limited supply, non-renewable. Right, again, there's lots of words. Lots of words, and you also need to learn the formulas. Okay, the bit all about advantage and disadvantage, a lot of it is kind of common sense. Fill that in, then what you need to do is you need to go to the other blank video, right, and that blank video, test yourself by pausing it on each slide, write your answer down, right, and again, read around. It's never going to harm you to read around and get more information.